A non-deterministic Turing machine is a theoretical model of computation that extends the capability of a deterministic Turing machine. So at each step, a non-Turing machine can explore multiple possibilities of computational paths simultaneously. It has 7 tuples, that is, Q is a finite set of states, sigma is an input alphabet, and then we have a symbol like T, which includes the tape alphabet, again rho, which is a transition function, and Q0 is a initial state, and Q accept is a accept state, and Q reject is a rejecting state. Now we have a deterministic Turing machine. A deterministic Turing machine is a classical model of computation where the machine's behavior is determined by a single transition of each input symbol in each state. In a deterministic Turing machine, there is no ambiguity in the machine's behavior at each step, and there is only one possible transition, which is unlike the non-deterministic Turing machine, which has more than one possible transitions. Now we have linear bounded automata. A linear bounded automata is a restricted form of Turing machine where the tape is bounded by the input size. So we have a limited size of input tape, and in a LBA, the tape head cannot move beyond the boundaries of the input string. The question 6 says, give 2 examples for each of the following. The first is decision problem. So the first example for decision problem can be a halting problem, that is given a program and its input decide whether the program will eventually halt or run indefinitely. Next is the traveling salesman problem, which is a very classical problem of city and a traveling salesman. Next is optimizing problem, which can be a knapsack problem and a maximum flow problem. And next we have undecidability, the 2 problems can be post correspondence problem and the decision problem, in which determining whether a given state in first order logic is universally valid or not. Next we have P and NP. So P can be a primality testing, given a number, determine whether it is a prime number or not. Or next is the integer factorization, which is for NP, which can be a given number if it's prime factor or not. Now we have NP and NPC, which is NPC is NP complete. First can be a Boolean satisfactability, that is SAT problem, where a Boolean formula determine if there is an assignment of truth values of its variable that makes the formula true or not. And the next one is subset sum problem. For the recursive language, we have a set of all palindromes over the alphabet 0, 1 are all the examples of recursive language, and next one is the set of even length strings over alphabet A, B, which is an example of recursive language. Next we have to explain the Chomsky hierarchy. The Chomsky hierarchy is a classification of formal grammars, which are systems that generate strings of symbols according to certain rules. There are 4 levels in the Chomsky hierarchy, each representing a different type of grammar. So we have 3 types of grammar: type 0, type 1, type 2, and type 3. Type 0 is unrestricted grammar called recursively enumerable language. Type 1 is context sensitive grammar. Type 2 is context free grammar, and type 3 is regular grammar. Now in the question 7, it wants us to define PDA, 2PDA, and NPDA. PDA is push-down automata. Push-down automata is a type of automata which is a mathematical model of computation. It extends the capability of a finite automata by adding a stack into it. So we have a stack where we can add the inputs and where we can store the data to make sure about the previous state. And we can do these stack operations, that are push and pop and seeing the topmost stack data. Next is 2PDA, where we have the variation of PDA where the input tape heads at both directions restricted to moving only to the right. NPDA is non-deterministic pushdown automata, a PDA where symbols can be multiple possible transitions from a state of given input symbol and a stack symbol combinations. NPDA is more powerful model than deterministic PDA, and they recognize the same class of languages as deterministic PDA, namely the context-free languages. Recursively enumerable languages.